Welcome to Deep Engineering Podcast, where we bring you conversations with people shaping ideas, systems, and the way we build modern software. Today, I'm joined by Evan Williams, author of Design Patterns and Best Practices in Rust. Evan brings deep experience in building reliable, high-performance systems and has been actively contributing to how developers approach design and architecture in Rust. Evan, it's great to have you here.
Oh, it's great to be here and a pleasure to be able to talk to you today.
Great. Evan, I want to give you the floor. Could you please start by telling us a bit about your background and your journey into software engineering?
Absolutely. I have been in the software business for horrifyingly more than 40 years. And surprisingly, given that, how my journey started was when I was 14 years old. Within the 1970s, I started programming. My father was a very skilled electrical engineer, and we built a computer in the basement together, which had a 6502 processor and 1K of RAM. And he hoped that I would become an electrical engineer because of my interest in the electronics. I became a programmer because I thought the programming was the most fun part. Um, I have since then grown up with the industry, I mean, not from the very beginning of it, but certainly from fairly early on, and in particular, sort of grown up with professional software development, sort of from the beginning. I've touched every part of the stack, many programming languages, many systems, and I am intensely interested by this. If they didn't pay me to do it, I'd do it anyway.
That's interesting. Thank you for that introduction. You've worked with languages like C and Python.
I have.
So what initially drew you toward Rust?
Well, very early on, I'm interested in programming languages in general, and I had heard about Rust almost at the very start, and I looked at it and I said, "This looks kind of mildly interesting. I'll just remember that," and then I forgot about it. But years later,
Mm,
Rust was like, becoming, not quite, it just barely reached 1.0,
mhm,
and I was working on a hardware project, and the hardware project had a few interesting characteristics. It needed to be in a location that we couldn't access easily. It wasn't going to be on the internet. It needed to be rock solid because people depended on it, and
mm.
it was remarkably complicated software. So the team that I was on talked about it, and we made the decision to go with Rust, which we none of us knew at the time, and so we all learned it together. And that was where I caught the Rust bug and have not lost it since.
That's interesting. And what other motivations do you have to write a book on design patterns in Rust at this stage of your career?
Well, I mean, there's sort of two questions tied up in there. One of them is, why would I be writing a book at all in this stage of my career? And
Mhm.
the answer to that is, I have been remarkably fortunate to have people help me throughout my career and help me grow. And it makes me incredibly happy to be able to pay that forward and help the people who are who are, you know, learning at this point, to grow themselves. And this book is a vehicle for me to help people. Why Rust design patterns? Because I think that the interesting thing about dealing with design patterns in Rust is, very often they're not what you need, and very often they're the thing that the traditional ones are not exactly what you need, and very often they can cause you problems that you didn't have to have. So I wanted to save people that frustration and help them move along the path in a way that is a lot less painful by not making the same mistakes that I made.
Interesting. That certainly is encouraging and helpful. Now, let's just dive a little bit deeper because we want to talk about Rust adoption as well as industry perspective. So,
Mhm.
Rust has been around for some time, but is also now seeing increased adoption recently. So, why do you think now is that moment for Rust?
I think that for a long time, there were a lot of people like me who were excited about Rust, and there were people who were early adopters, who were, pushing for it. But right now, what we're seeing is a world where it's been, it's the language has matured, the ecosystem has matured, it's reached a kind of critical mass. Now, when someone is thinking about doing a Rust project, they're not pioneers who are wandering out into uh, lands unknown. Now there are people. There's a huge community. There's a huge set of packages and software. There are great learning resources, and there are people who have had success that you can see who have uh, done amazing things with Rust. So I feel like now people feel more confident and feel safer um, venturing into using Rust for things, whereas before it was a little bit more of a risk in their mind.
Interesting. And in your experience as well, what gaps does Rust fill compared to more established languages like C++, Java, or Python?
Well, that's interesting. I mean, I could just go over sort of the normal thing and say, high performance and memory safety, all those
Mhm.
things are true, but Rust is also a powerful modern language that has a good feature set. And I feel like there's a design gap of
Mhm.
sorts. Um, One of the things that's great about Rust, and I probably keep returning to this topic, is um, if you need something to be correct, if you need to be able to count on the code that you write, Rust helps you. Rust is your partner in doing that. You can still write code with bugs in it, but Rust makes it harder to do that and easier to do code that's going to be solid. I think that that's a huge gap that it fills.
Yeah, thanks for shedding light on that. And also, maybe if you could give us some example or use cases, like what kinds of systems or use cases benefit the most from adopting Rust today?
Well, I think, systems that are mission critical in some way or other are really sort of, key Rust uses. Yes, Rust has, high efficiency. The memory safety is very important. uh, I think the thing is, all of these features combine into a whole that uh, making Rust a really powerful language for doing things that have to work. Things where failure is monetarily or in human cost even a terrible problem. Uh, that's one of the powers of the language, and I think it's great for those situations.
Thank you for providing that high-level overview. Let's just talk about also thinking in Rust and the shift that is required,
Mhm.
in thinking. So one of the recurring themes in your book is that developers need to think differently in Rust. So
Mhm.
tell us, what does that mindset shift really involve?
Well, there are a few things associated with that. One is uh, it, Rust is not an object-oriented language. It kind of looks like an object-oriented language in some ways, but it's not. And if you carry with you an object-oriented language mindset, then you're going to have nothing but trouble. Um, it's also a language that requires you to think carefully about the design of your code before you start writing it. It's very easy to get yourself into trouble in Rust if you don't plan what you're doing. You have to start thinking about data and how it's handled in a different way. You have to think ahead of time about where's the data flowing through your program? Where is it going? How long is it going to live? Who's responsible for it? These are things that you don't really have to think about when you're writing a Python program or a Java program. Those are good design principles in all of those languages, but Rust requires it of you.
Yeah, interesting. And many developers also struggle with the borrow checker early on. So how should they reframe it as a design tool rather than a limitation?
The thing about the borrow checker is it's there to help you. And it
Mhm.
is very easy to get into a mode where you're fighting with it and you feel like it's your enemy. But
Mhm.
in fact, what it is doing is encouraging you to build your code in a solid manner. It's encouraging you to think about not just, what data I have, but how it's going to be used. One of the things about, um, say, Java or Python is you can get with some amount of plumbing, you can get at anything from anywhere. You don't really have to design your program in a highly organized way where you've thought about the data flows, but you're much better off if you do. I think the principles that the borrow checker forces you to adhere to in Rust are the exact principles that you should be using in every programming language, but you don't have to. It's very easy to not think about those things. The borrow checker is your friend because it prevents you from making a messy design. It prevents you from making a broken design. It prevents you from writing whole classes of bugs that you will then spend many hours trying to find. Um, I have found it to be an incredible partner in writing code that allows me to sleep at night.
That's interesting and insightful. And also, what might be the common mistakes developers make when they try to apply patterns from other languages directly in Rust, in your
So
experience?
Yeah. So no, that's a great question. And the the principal thing is number one, trying to use Rust as if it's an object-oriented language. It's not going to work. Viewing the compiler errors that you're going to get as things that you need to figure out how to work around, which is something that virtually everybody who starts with Rust, especially, and I can't emphasize this enough. One of the things that's sort of interesting about Rust is like the more experienced you are, the more years you have doing some other language, the more trouble you're likely to have because you have patterns of thought that come from those languages that you don't even realize are there. Um, that's one of the things that can really get you into trouble. I think treating the compiler errors and the problems with the borrow checker as things to work around as opposed to signals that your program needs some redesign, and thinking about things from an object oriented perspective.
Thank you. That's helpful. And let's just talk about design patterns in Rust.
Sure.
Uh, uh, Traditional design patterns, were created with object-oriented languages in
Mhm.
mind, right? So how do they evolve when applied to Rust?
So it's you know, in a number of different ways. First, some of them evolve, sort of uh, into entirely new forms or almost out of existence because being a modern language, Rust has things like the Rust enums, all sorts of uh, very advanced use of generics. These are things that make a lot of these design patterns either less necessary or unnecessary. Another way that it evolves is honestly there since there is no inheritance in the language, you have to rethink a lot of the design patterns where say you would have an abstract base class. You can't
Mhm.
have that because there's no such thing. So you would lean into traits, and every single design pattern that you use is affected by the borrow checker and by memory discipline in a way that it is not normal in something like Java or Python.
And are there any patterns that become unnecessary or even counterproductive in Rust?
Well, the one that immediately springs to mind is singleton, which is so useful that I was using it before it had a name. Um, but it's useful in Python or Java. In
Hmm.
Rust, it tends to be either completely unnecessary because other features of the language make it unneeded, or it it tends to encourage designs that are really not necessary, and where a much better uh, way of thinking about it could be a better approach could be used. And so, yes, there are a few occasions where the singleton pattern, as it stands, is actually useful, but more often than not, it's getting you into trouble.
Thank you for highlighting that. And tell us maybe also about any Rust-specific patterns you think are the most powerful and still underutilized, maybe.
So, so the one that I get so excited about that I like have to limit myself so that I don't spend the rest of this conversation talking about is the type state pattern. This is something that was not invented for Rust, but it existed before Rust, but you would think that it had been because it works for Rust so perfectly. It's a way of developing state machines and systems that have state that evolves where invalid state transitions aren't just errors, they're impossible to write. The compiler won't compile them, and it represents a huge advance in the way that such systems are written, because now instead of runtime errors, you have a state machine that is guaranteed to work because every transition either is a valid transition or it won't even compile. That's an amazing thing, and I love that feature. Uh, as I say, not invented for Rust, but it fits Rust so perfectly. It's hard to believe it.
Thank you for underscoring that. Uh, Evan, let's also touch base with architecture and system design.
Of
Your
course.
book, your book emphasizes clear data flow and system architecture. Why is unidirectional data flow so important in Rust systems?
Well, thinking about the way data flows through your system in Rust is crucial because it's Rust makes it much more difficult to um, thread things back. You, as a general rule, because you can't have many different clients holding on to different things in different places, especially not being able to write to different things in different places. Having a clear direction of data flow makes it much clearer and much easier to create a consistent system that's going to compile and work. By saying, I have a chain of ownership that moves down but never moves back up, what that means is you are now much more likely to have a system that is going to work in an environment where the number of references that can be held is very limited, and you have to be very careful about memory safety. Data flowing down is something that feels natural and smooth and just works. Data trying to fight the stream back up is going to end up giving you problems because the borrow checker is not going to like you.
I think it might be of help if you please would expand on how Rust's ownership model influence architectural decisions at a system level as well.
Absolutely. You know, it's, I think one of the sort of crucial things about it is um, because you have to be so thoughtful about how your data moves, who owns it. You have to also think about, well, what does that mean for my system? You need to think about who 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 controls what, how it is controlled, and you need to start from the very beginning thinking about the boundaries of your program and the system architecture, dividing things up into areas of responsibility, because having, unlike Python or Java, for example, you can't have links going all over the place. The borrow checker is never going to accept that. And Rust gives you lots of great tools for creating boundaries of abstraction that make it a lot simpler to write code that doesn't have hidden um, or difficult to find connections between things. You know who owns things. You know who is able to write things. In order to do that, you effectively you have to be able to think about things ahead of time and think about what parts of your program own what, and create clear boundaries and areas of responsibility for each system, each piece of the system that you build.
I, I think it would also help if you could please share an example of how Rust leads to a better system design compared to other languages.
So one of the things that one of the examples in the book, one of the projects that we build in the book is a miniature publish and subscribe, system, similar to Kafka, but
Mhm.
very, very much smaller. And it is amazing how easy it becomes to make something that is solid and clean in that circumstance. So, because Rust has move semantics, you know that if something leaves here and goes here, it's now not here anymore. It's there. There's no question about things like being it having references dangling or things like that. The clarity of uh, the clarity of things moving through the system, uh, the clarity of being able to uh, have immutable data in a lot of places, and knowing who can and can't uh, modify any piece of data. It just makes the design of the system so clear, and it makes it so much harder to make a system that doesn't work. Um, by doing things that way, you have something where you have can have a potentially very complicated system, and yet have complete confidence that every piece of it individually is going to work right and they're going to work together as a system.
Thank you for pointing that out. I want to also talk about the practical aspects of things and also real world applications. If you could please also tell us, like, what are some real world challenges that engineering teams face when adopting Rust in production?
Sure. So one thing that often happens is, the when a team adopts Rust because of the, challenges of, learning to work in the language, velocity can go down at first,
Mm.
and the team can find itself actually moving slower. Uh, After the team becomes very well acquainted with Rust, then velocity can increase dramatically. But there is a period of time where it seems like things have gotten worse. I think another problem that often happens is that, as I said earlier, more experienced developers often have a harder time adapting to it. And I guess the last thing I'll mention, although it's a lot better than it used to be, is Rust is still not 100% in terms of the kind of rich libraries that you can find in, say, Java or C++, which are just older languages. And so there's
Mm.
more out there that supports the language, although Rust is certainly catching up, and it's remarkable how far it's come.
Yeah. Thank you for also highlighting about velocity over here. And I would appreciate it if you could also tell us when would you advise against using Rust, maybe for a project?
So there are a few things, right? If you're doing some kind of, prototyping, Rust is harder to prototype and you really want something more like Python.
Mm.
Um, if you're working in certain niche environments where the tooling is not there, that's a that's a place where you don't want to try to sort of fight with the tooling to try to get, Rust to work. It's good to just work with the native things that are there. I think, there are places where a dynamic language, for example, a dynamic language like Python is just, a much easier thing to use and will more perfectly fit what you're trying to do. And I also think that there are a few areas where Rust has the potential to do a lot, but so for example, like, user interfaces, there are certainly user interface frameworks and libraries. They're catching up, but doing doing a website in Rust is still kind of a feat, and it's an awful lot easier to use the tools that everybody else is using to accomplish that goal.
Yeah, thank you. That's helpful. I also want to ask about teams that are transitioning from other languages. What's the best way to introduce Rust without probably overwhelming your developers?
So I think the thing that you need to do to start is find a project, a piece of work that you can work on that has a limited scope and which has is not in the critical path, because there are going to be roadblocks and bumps as people learn. It's going to and you what you don't want to do is jump into saying, "Oh, we're just going to rewrite our project in Rust now." um, Pick a small piece, focus on that, gain confidence and mastery of the language, and then use that to build upon it and start bringing in more things.
Interesting. And how should developers balance performance, safety, and complexity when designing systems in Rust?
So, one of the nice things about it is that uh, all of those things sort of come with the language. I think the thing that developers need to do is focus on letting the language help you. Um, Rust will give you all of those things if you focus on thinking in the language and using patterns and features that are natural to the language as opposed to trying to retool something from another language that's uh, that doesn't really fit. There are so many things that people try to do to get around problems that they have, where if they just use the features of the language as they exist and did things in a way that's more natural to the language, those all of those things just fall out um if you think about using Rust in a way that's natural.
Interesting. And Evan, how do you see Rust evolving over the next couple of years, especially in terms of adoption as well as ecosystem? I know you answered this earlier a little bit, but I just want to bring it back because this is very important since we've
It
almost
it
come to the end of our discussion.
it is, and I think that there's a couple of different ways that you can answer that. I think one of them is the ecosystem is going to get more rich, and people are going to be uh, branching out in the set of use cases, hitting areas that right now Rust has relatively weak support for, but which I think people are building on all the time. I think as larger and larger projects are built, there is going to be more, uh, first of all, more refinement of the language itself, but more importantly, more refinement of the use of the language. And I think this is sort of important. This book that I wrote is not just about um, the language itself, but the way to use the language. And I think that the um, the Rust community and the people who are building in Rust are going to be defining and creating new ways to use it that are unique and leverage its power to do things that right now we haven't even thought of.
Speaking about the book, did any of your own assumptions about Rust change while you were writing the book?
Well, it's interesting because, one of the things that changed is I came to recognize when the early chapters of the book are about what not to do. And one of the things I found is that um, in Rust, it's actually more work to do things wrong.
Mm.
Um, and I think that's one of the things that surprised me. Um, I knew that you had to think in a new way and do things differently. But when I went back and tried to write when I tried to write bad code in Rust, it was much harder than writing the good code. That's an interesting perspective that I just didn't even occur to me.
Interesting. And maybe if you could tell us, for developers picking your book, what key takeaway do you hope they would walk away with?
Absolutely. So I think the key takeaway is that um, the thing that you want is not to learn a particular set of patterns. My book is full of what the title says, right? How to deal with design patterns in Rust. But the much more important thing is changing your mindset. If I can if I can help people to recognize that there is a new mindset that they need, um, that's the key thing. And I see so many people who become frustrated with Rust because Rust has such an unusual learning curve. You
Yeah.
start out in most languages, it's sort of a steady progress. Maybe you plateau a little bit, but you're always going up. With Rust, very often it seems like you're learning and learning and learning and learning and getting better and better. And when you reach a certain level of complexity in your programs, it feels like things are getting worse. And that's because of the mindset. And I feel like helping people understand that will save them so much pain. That's what I want people to take away from the book.
Awesome. Well, I think we've come now to the end of our discussion. And before we wrap up, I just want to ask something that I sometimes like to ask our
Please.
authors. Is there something that most people, most developers don't know about Rust, or is something that is very underestimated?
That's a great question. I think um, the thing that people perhaps underestimate about Rust is it's not just about memory safety and all these other things. It's a really powerful modern programming language. Uh, it brings so much to the table that has nothing to do with memory safety or thread safety or any of those other things or high performance. It's just a very clean, beautiful language to write in because it brings so many modern innovations that other languages are sort of stuck having to drag along historic pieces of um, historic syntax. Um, Rust is Rust is a pleasure to write in. It's just sometimes the borrow checker can be a little annoying.
Awesome. Now, Evan, I thank you so much for joining us today, sharing your insights. It has been a edifying conversation and exploring your perspectives on Rust, system design, and building better software. And also to our listeners, thank you so much. If you enjoyed this conversation, make sure to subscribe to Deep Engineering, our weekly newsletter, where we explore topics like software architecture, engineering practices, and how developers evolve into stronger engineers. We also have published a dedicated deep engineering issue based on our conversation today, capturing the key insights Evan shared. So look that out. It's on deepengineering.substack.com. Thank you again for joining us, and we'll see you in the next Deep Engineering podcast episode. You should. Some.